Today we will be learning about the 9-1D wave equation. So the essential questions for this topic are: how are waves measured, how are wave speed, frequency, and wavelength related, and what happens to frequency if wavelength is changed. First, let's talk a little bit about wave speed. So wave speed depends on the medium it's traveling through, so this means that the speed of the wave depends on whatever it's going through. The closer the atoms of the medium are, the quicker the wave moves through it. So the speed of the wave will increase if it's traveling through a solid, since the atoms are much closer together compared to liquids and gases, since those atoms are further apart. This happens because in solids the atoms are much closer together, so there's less of a gap for the wave to have to travel through or jump through in order to achieve its destination or wherever it's going. This is why we see people put their ear up to doors or walls and use doors and walls so they can hear better, and use the telephones with the cups and the string, because these are all solids, so the sound waves and vibrations will move much faster through them. Wave speed is a product of wavelength by frequency. So this gets into the actual equation, which is velocity or wave speed equals frequency times wavelength. We have this handy dandy triangle here which helps us see how the equation is used and how we can solve for various parts of the equation. So to start, when we're solving for speed or velocity, we multiply the two bottom factors, which is frequency in hertz, and wavelength, which is represented as lambda, the sign underneath wavelength, but it is measured in meters. So we multiply these two together to get speed, which is on the top. Sometimes you'll have to solve for frequency or wavelength. So in order to do this, say you were solving for frequency, you would take speed in meters per second and divide by wavelength on the bottom, and this would equal frequency in hertz. Now if you're solving for wavelength, you would take speed in meters per second divided by the frequency in hertz, and you'll get wavelength in meters. This gets a little more complicated when we're talking about the frequency, because sometimes you won't be given the frequency and you'll have to solve for it. So in order to do this, frequency has its own formula, as shown in this picture here. Frequency equals 1 over periodic time, or the time in between waves. This will always be in seconds, and a simplified version of this equation is F, or frequency, equals 1 over T, which is the time, and once you solve for frequency, it'll be in hertz. Now this works vice versa, with periodic time equals 1 over frequency, or time equals 1 over F, which is frequency, and once you solve for this, it'll be in seconds since it's time. When solving an equation and you're given the periodic time or period in seconds, use 1 over T. So in some instances, you'll be given the periodic time, which will be in seconds, and you'll have to find the frequency. This will either be on a question on its own or part of solving for the wave speed. So in order to convert the periodic time into frequency, you put 1 over time. So that, say the time that you're given is 5 seconds in between waves. In order to convert it, it's 1 over 5, or 0.2, once you put it in a calculator. When solving an equation that asks for period or time and you have the frequency, use P equals 1 over F. So this is the opposite of the first portion of this slide, where sometimes you'll be given the frequency or you'll solve the frequency, but the question is asking for the period or the time in between waves or something like that. So in order to do this, you also have to convert back to periodic time, and the way you do this is you put 1 over F. So say you solve for frequency, or they gave you the frequency and it's 2. In order to convert it to periodic time, you put 1 over 2, which equals 0.5 once you put it in the calculator. You'll see this a little better once we get into the guided practice here. So, problem number 1. Damian and Roman are throwing rocks into a lake, making waves. While doing this, Damian measures the wavelength, which is 5 meters, and figures out that each wave passes every 3 seconds. This would be the periodic time. What is the speed of the waves? So I have this here filled out for you. I'm just going to run through the steps so you can make sure you're doing it right and understand it. Step 1, list the variables. So we have V as a question mark right now because that's what we're looking for. And on the third variable, lambda, we have 5 meters because that was the wavelength. For frequency, it gets a little confusing, maybe because it doesn't give you the frequency, but it gives you the periodic time, which was 3 seconds. As we saw in the frequency slide, we can convert the periodic time into frequency by putting 1 over t. And since t equals 3, or 3 seconds, frequency equals 1 over 3. And once you plug this into the calculator, it equals 0.33. Step 2. Place in the chart or the equation. So we have the triangle here on the left. And on the bottom left of the triangle, we have frequency as 0.33 hertz. And then on the bottom right, we have lambda, or wavelength, equals 5 meters. Velocity is blank right now because that's what we're solving for. Step 3, multiply. I wrote it down in the equation just so you can visualize it a little better. So the velocity equals the frequency 0.33 hertz times the wavelength 5 meters. And this equals 1.65 meters per second. And that goes in the velocity part of the triangle. And this is how you use this equation.